Hi everyone, welcome to the stream. Hopefully everything works. Let me know. Yeah, I guess we're gonna wait a few minutes again to get some more people in, and then we can get to the fun stuff. Yeah, while we wait, I can show some of the things, how some of the upgrades I've made to the home lab over here. As you know, no sound. Really? Is there really no sound? Because I can see in the OBS that the equalizer is moving. Yeah, okay, there is sound. I guess it's just quiet. Maybe I'm not as close to the microphone as I should be. A bit low. Yeah, sorry. Just, I guess, increase the volume. Not much I can do here. Okay, loud and clear. Yeah. Okay, it's all around the place, so who knows. Yeah, so in the last stream, what did we open? We opened the microscope. Yeah, you can see it here. And the screen, I have it to the side here. So right now I have the chat here and like my confidence monitor, so I can see what is being streamed live. So I can see that I'm very red for some reason. This camera is not great. But yeah, since then, since last time, I made some 3D printing to make my home lab better. So one of the things I printed is this. I actually designed this stand for the TS100. So I showed, I think, at some point also on a stream, a different stand, which was this smaller one, also with this wool. But the angle on that one, I didn't quite like it. It was very flat, so it was hard to, like, you had to put your hand very strangely to put the iron down and pick it up. So this one, I quite like it because it's, like, if you see, it's the angle that you're holding the iron as you're soldering. And there is a bearing there that so far has been working pretty good at keeping the heat away from the plastic, so nothing has melted just yet. But yeah, I should say hi to the people in the chat also. So what do we have here? Yeah, so hi Johnny, hi Rotter, hi Adam, hi Conrad, hi Jerry L, I'm not sure. Hi Keaton, Charlotten, Henrik, hi. William, hello. What's the difference between MicroPython and CircuitPython? That question comes up a lot, and I still don't have the great answer. That's like a short and sweet answer. The difference is definitely in the APIs. So CircuitPython has forked away from MicroPython, and they threw away kind of the APIs for UART and SPI, I2C, and then Adafruit wrote their own, which are focused on being easy to use and easy to understand, so like straightforward. And then yeah, like the big difference is also that CircuitPython is maintained by Adafruit, so it's more focused on being easy to use and easy for education and like a starting thing. MicroPython goes more into kind of performance and being more for hackers, I would say. Thanks Adam. These Sennheisers, actually I had them for like 2 years, and the cushions here are starting to kind of fall apart. I hope I can find replacements for them, because I like the headphones themselves are pretty good, so I don't want to get rid of those. Hi, Bwack. I'm not sure how to pronounce that one. Yeah, exactly. CircuitPython is Adafruit and MicroPython is the mainline stuff. But there is quite some differences in the way the code is organized also, even though CircuitPython syncs with the upstream with the releases, but yeah, they do quite a lot of changes. Where is my mouse? Wanted to see how many we are. That's the wrong window. We are 27. Pads are available on Amazon. Awesome. Then I have to order. Great. Yeah, I'm really happy. Like, the only kind of problem I'm having, well, not problem, like the headphones I use at work, even though obviously I work from home now, but are wireless and I got used to that. So being on a cable is a bit annoying. So I wish these were also wireless, but I'm really happy with them. So there's no point in upgrading just yet. Oh, that's the stuff. 450, I think that's with the noise cancelling and all that. These are not great at noise cancelling. Actually, it's not these. I had ones before that had like holes here, so definitely not noise cancelling, but I can't complain. Yeah, CircuitPython is also in Swedish. Yeah, I don't know about MicroPython, they're saying translations there, but CircuitPython definitely has a lot of translations. So yeah, very accessible and nice to start with. Yeah, exactly. I don't want to pull stuff off my... Hi, Savage Electronics. Yeah, we're 8 minutes in. Wow, that goes fast. All right, so I showed the stand. I also have here something I'm really happy with, and it's this organizer for SMD parts, because when I solder, I mean, there's so many common parts you use, like 10K resistors, 0.01 UF capacitors and all that, and I don't want that on a reel, and removing from the tape is annoying. So it's really nice to have some way to store them. And I found these did I switch maybe to the overhead cam? I found these 3 milliliter paint contain. Actually, this one's hard to remove. Paint containers on Amazon, and they were great for holding SMD parts. So you can see here, it's like a tiny 3 milliliter, but there's hundreds and hundreds of capacitors in there. This is like 12 pico, which is quite common for crystals. So this model is available. There's a link in the description for both the containers and for like the boxes, and for this container. It's 3D printed, of course. And it can hold 60 of these containers. So that's a lot of components. And I'm really happy with that I can have a lot of components easily in a small space. Damn, this mirrored camera is tripping me off, but yeah, you can see. Yeah, very nice. And I have them labeled. I think it's mirrored in the camera, so sorry about that. Hi, Sylvain. So we will be using, oh, that one fell out. I will be using the components from that one today. And then, I don't know how much cable I have. Okay, I will switch now to the overhead and I can show it. Let me just, exactly, this is annoying. That's why it was moved off camera, because it's up there. But if we switch here, perfect. So what I'm using right now for the stream, as I just posted this on Twitter like a few hours ago, is this nice, it's called Free Deck, and it's a macro pad, I think that's the term. that it allows you to create custom macros. It uses 6 screens and there's buttons under them, which is a bit hacky, but it works. So why not? And right now I have it set up, like I set it up for OBS, so I can switch nicely between the scenes in OBS via shortcuts. So it's just like at Mega32U4 some displays, and it reads the config from the SD card. So hi Bleep Track. So I'm really happy with this one because it's super simple, it's super cheap, and it's exactly what I needed for easily switching, like controlling the stream. Let me just side here. And yeah, I guess it's time, 11 minutes in, to get to the part that's actually in the thumbnail. So yeah, buttons under the screens are quite hacky, but like the actual travel of the buttons is like 0.5 millimeter or 0.3 even. So yeah, maybe over time something breaks, but we'll see. It costs like $15 total with PCBs and parts. So even if it breaks, I'm not gonna cry that much. Let's see. Yeah, the clicks are, because I guess this mic, it picks up mostly up front. So since it was in the back. Soldering station, yeah, this is the first soldering, no, not the first soldering stream. Actually, I had the previous one with the other microscope that didn't go so well. It was 6 hours. We'll see if today will be 6 hours also. But today we will be bringing up the Serpano, which is I tried to make a pun. I have no idea if it works. You figure it out. And I should mention that the boards were sponsored by JLC, so they didn't ask me to really say anything specific, but oh, hi Timon, hi Professor Sparkles. I just want, like, if you follow me on Twitter, you know I use JLC all the time for all my boards, and they don't have to pay me to do that because I'm really happy with like their price, their turnout time, and their shipping speed and quality. There's no problems. Like, it just works. So if they sponsored me or not, you would probably see this box anyway. So yeah, it was sponsored, but I would have done it anyway because I'm really happy with them. So, oh yeah, and I should mention, they actually gave me a coupon that I am supposed to share. So I guess I will tweet it about later, but if you want to get a $2 off coupon when you order from JLC, you can use the code, wow, we are 36 online, wow. We can use the code JLC Arturo, all one word, and you will get $2 off your order. And it just so happens that the first 5 boards you order are also $2. So in practice, the boards are free, you just pay for the shipping. So that's something. If go for it if you want. But yeah, there's a cool tape. Not sure why it's electrical tape. I think it looks like electrical tape. Previously, they used to give the like masking tape, which was quite useful. Hi James. Hi Colin also, which was quite useful for holding down stencils. But now they give electric tape for some reason. And yeah, they have funny comics here. And it doesn't focus. Never mind that. And I actually did order stencils, but since this is the bring up and it's on stream, I'm gonna just solder by hand this time. And I actually haven't opened the boards yet, so very exciting. Let me just what's happening in the stream, in the chat. Where is my mouse? High applied procrastination. Thanks, Colin. It's okay if you can't stick around, but thank you for popping in. just reading the chat. So yeah, I have the schematics here. We'll get to that in a moment. But since the boards were sponsored, I decided to go all in, and I got some Inig. So they're blue solder mask with Inig gold finish. So that's quite nice. It looks pretty. It doesn't look so great on this camera. Like, it's very dull gold. It's not as nice as in the render, because it never is. But yeah, let's go for it. Hi, Tablatronics. Yeah, of course, all by hand. But this board lends itself really well to soldering by hand because it's quite modular in design. So there's three ways that powers goes in. There's USB PD, or there's USB PD here. There's a battery with charging, and then there's a DC in. So that's like, I don't have to solder all three at the same time. I can start with the USB and see how that goes. Then there's a DC boost that boosts whatever goes in to 15 volts. So that's another block that I can solder and test. And that's how we will do it in the stream, actually. We will go block by block. Hopefully everything works. And then, yeah, and then we have 3 voltages buck. So 2 of them are, there's 3.3 volt, which is used for, I call the logic for the SAMD, which is here. And then there's 5 volt, which is used to charge the battery. And then there's one that's adjustable. And there's a digital pot that will control the voltage divider for the buck. So that's how we control the voltage. And then there's a current sensing here. And then this is like, if you remove these 2 pages and just had this is just a basic CircuitPython circuit. So it's a SAMD 51 with LCD, QSPI, flash, and there's a NeoPixel, and that's pretty much it. So I think it's gonna work really nicely going step by step and seeing how that works. Per real world perfect renders, it's never that nice. Sorry, just checking the chat. Yep. So we can have a look at the board. I will switch to the microscope soon so we can actually have a look at the board up close. But I can maybe hide this. But I can quickly explain, since I just explained quickly kind of how the schematic looks, we can explain how it is on the board here also. So right, this is the top. So we have the USB. I don't think that's at all in focus, but yeah, we have the USB with the PD here. Then we have the battery with the battery charging circuitry. Here there's a reset button, there's a NeoPixel, standard stuff. Then we have 3 buttons that my idea is you can have up and down and then enter and like long click to exit, just to navigate menus on the screen. And then you have the DC DC in. There's a fuse. I have a few fuses. We can start with like, I think 1 amp would be, you never know what happens here. There's a proper like on-off switch that's like actually latching. So if something starts smoking, you can quickly turn it off. Hopefully that doesn't happen, but we'll see. And yeah, this is the boost right here. And then on the back, there's loads of stuff. So pretty much everything here is the buck. There's 3 inductors and just DC circuits. The current sensing is also here. And then we have the display connector. There's the SAMD, the QSPI, and that's pretty much it. And this is supposed to, actually we can try this immediately. This is supposed to fit in a breadboard. Notepad represent. There it is. So I actually have a switch quickly here. So I have a breadboard here with headers that I already arranged when I was testing a paper print of the design to see if it would work. And we can have a quick look. Let's see. There we go. It was just a problem of moving up and down here, but there we go. It fits nicely. So whoop, there we go. So that's good to know. The annoying thing that I learned when designing this is that there are two ways that breadboards are laid out, so to speak. And that is the way the power rails are aligned to the, just these common ones here. Show the OLED button. Yeah, in a moment, Mark. And one of the ways that is here is that the power rails are actually in between the other rows. So they're not aligned, but there are also boards, and I've seen mostly the ones that are like half size, but I also seen big where the rails are aligned to the common rows here. So to be compatible with both, I had to there we go. I had to make two options here. You can see for the headers. Oops, did I just restart? Yeah, it's okay. My free deck just restarted for whatever reason. Maybe it's breaking already. But yeah, so you have to know which when you like buy this, you have to know which one you want to use it with, and then you solder either the ones that are on the out or the ones that are on the like inside, and then yeah, that aligns with your breadboard. What did I do? Not 555. Lots of action in the chat. Have I demonstrated the OLED button? Yes, okay, I will show that in a moment. Right. Oh, hi, Mark. Not sure if I said that already. Yeah, it's a physically, so when you press it down, it stays down, and then you have to like depress it to turn it back on. Hello from the garden, yeah. Yeah, so I can quickly show this one again. There you go. And yeah, the flickering is not really here like in real life. It's just the camera as usual. So this is the free deck. Again, micro SD, some maxing here, because I mean all 6 displays use the same I2C address, so they actually do the SDA pin is on a max, so you select via the max which one you want to talk with, which is quite nice. And yeah, no, it's not SMD actually, it's through hole. This one, it's those 6 here. It's pretty much the same as on those really cheap breadboard power supplies that are just like you just connect a DC jack and you get 3 and 5 volts. So it's the same, it's just a bit smaller because those are 8 millimeters by 8, and this is 5.3 or 6 by 6, something like that, just slightly smaller. But yeah, here's the free deck, and I can go back. I can go OBS. I have a folder here that there's nothing in there, and then the OBS, and I can switch. Right, I'm already here and back. Yep. So that seems to work quite well. simple solution. Yeah, the blue tip ones. Mine are, I think, white tipped, but that doesn't matter. Okay, but now we can then have a look. Make some space. I don't think I need this on the camera. And let me just share. I can move in the microscope way in here. And then, perfect. Just move the mic a bit out of the way. Yep, everything works. So let's have a look. Yeah, long-term pressing on the OLEDs, I have no idea. We'll see in practice. Is it in focus? It's mostly in focus. And here, okay, a bit overexposed. I guess it's fine. Yeah, it looks very yellow, but you can see there the gold. Nice and gold. I rarely use gold, so I'm just a bit excited about it. Okay, this is upside down. Yeah. So where's my pointer? So yeah, I think we will start with the USB, and then we have the power delivery chip, and yeah, then we'll see if we actually get the expected voltage from the power delivery, which I actually have to check. Right. I'm trying to remember because it's been, I don't know, like 2 weeks. So, you know. Right, I wanted to use a different power delivery chip that's like not a smart one that you just put pull up or pull down and you get the voltage expected. But as the chip, I don't remember now the symbol, but it's the same one that Brian Locke tried to use also. And my problem with that one was when I went to JLC to LCSC, they had like 3 in stock, and I need something that I can reliably get, and like you couldn't get it from AliExpress and so on, so that's a no-go, non-starter. So I went for a FUSB 302B. Can I show like this? Nope, that's the DC. Okay, that's a silly way to show it, but there it is. I went for this one, and this one is an I2C, so you actually have to talk to it to get higher voltage. But I believe the initial it starts at 5 volt, so that shouldn't be a problem. And yeah, then we go from there. But yeah, we will start with that. So we will solder the connector and then this chip and see what we get kind of on this diode. Hopefully 5 volts. Hopefully no smoke. So I get it in my trusty stick vise, which I highly recommend, and that's not sponsored, that's just I'm a big fan of the stick vise. There it is. And that's actually, I have to put it the other way because I wouldn't be able to solder. Let's see what tip I have here. It's a big one. I'm gonna switch the tip. This camera is quite boring right now. Maybe that's slightly more interesting. You can at least see. Oh yeah, there's one more. I get distracted. There's one more thing that I printed, and there we go. This nice portable TS100 holder, which had my tip. And yeah, as seen on Twitter. So it's a case, a 3D printed case that doubles as a stand. So it has this nice bearing attachment here, so you can, let's see if this isn't the first time I screw out this screw so much that it comes off, and I'm gonna lose it at some point for sure. But yeah, it doubles as a nice stand here, and that's actually how I got the idea for the bearing. But when you're not using it, you can just put it here, you put your TS100 in there, and you're good to go wherever you're going. And the link is also in the description if someone wants to print that one. Or actually no, the link is not in the description. That is true. Yeah, I can put it up later. But for now, let's get soldering, because we're 30 minutes in and nothing is soldered. The temperature, there we go. We give it a moment. And so yeah, actually we have to start with this QFN, so that for that we will need hot air anyway. Is the screw required? I haven't tried using it without. I don't know if I would trust it that much. Maybe it's not required, but if you're holding it down and you don't want that to fall on your board or on your hand or on your whatever, really. So there you go. I might need the even thinner tip for this, which I have, because you don't want too much here. Just like a symbolic amount. There it is. So now I need to find this in the big box part. Yeah, I have this. This is, you'll see all the parts that are in this design. So that takes some time to find what you're looking for. I haven't found a good way around this issue of storing things. Like, yeah, for one project I have a box, but then inside that box, as you can see, it's chaos. I will need that one. There it is. Yeah, the field of view is definitely cropped from. Let me switch there. I can see way more than like, all right. We're trying to find here to here. Actually, it's, I don't know, like half or like half a centimeter each way. But yeah, I noticed that as well, that I could see this one, but it wasn't there in the camera view. Okay, so the hot air, let me just move the microphone for a moment. It's gonna be interesting. This is like the first time I'm actually properly using this, the Banggood hot air gun. So let's see. Yep. Let's connect that one. There it is. Sorry if that's loud. I actually should have prepared. Hi, Brian. Pin 1 is there. Pin 1. Okie dokie. It claims the temperature is what it should be. And I'm using heat resistant cloth for the stick vise, so it should be fine. That I'm kind of blowing on the It's a 4-layer board, so it might take slightly longer to heat up, especially since this is connected to ground, so there's a lot of thermal capacity to fight there. Or maybe it's just too cold. Oh, that's a really late meeting, Brian. That's taking a bit longer than I expected to. What if we help it? Maybe it's lying to me about the temperature. Yeah. Okay, so you know what? I'm gonna mute just so you don't have to experience whatever is happening there. I'm not sure. Yeah, I'm not sure if it actually soldered because that was a lot. Oh, yep. God damn. I might have to put more. Maybe I removed too much. Problem is, if you put too much, it might just fall out. Like when you press down on the chip. Like this feels like it's too much. Let's just try it. Oop. There's the chip. Great start, everyone. Great start. Bye, Colin. I didn't mute, but I heard you said it's not that bad. This is ridiculous. I wonder if it's this hot air station or it shouldn't take this long. There it is. Yeah. See, this is the problem. I'm worried it will short now. Holy crap, this is not great, not great. Yep. Hi Deshipu. Hi Dave, Darko. Yeah. So it looks okay, but my only worry is that those pins are shorted to the ground, which we actually can check. So you know what, let's do that. Well, that's not great. Did I left it on and then... Hi Alex, I do have a stencil, but I want to assemble it part by part. And also I don't have an oven here, so that wouldn't quite work. So it seems the batteries in my multimeter died because it's stream live. Oh yeah, can you hear that sound also when someone subscribes? I wonder. Screw it. If it smokes, then we know it's shorted. So I'm gonna switch to a thinner tip for the TS100. Cool, so my plugins for subscriber animations and such work. That's cool to know. straight in there. Yeah, so this is the fine tip. Fine tip tip. Let's see how this goes then. So the hot air was set to 370, which, like the one that we use at the hackerspace, I use at like 350, and that's no problem. But maybe I cannot trust this one. But then if I set it hot, if I set it higher, maybe it just melts. So who knows? Just waiting for the tip to heat up. There we go. Microphone is quite big and in the way. Man, this chip is really tiny. Really, really, really tiny. So yeah, first one we hand solder, all the other ones we stencil. At least my drag solder is still on point. Pretty small. But I gotta say, I'm really happy with having the monitor here to the side so I can see the live feedback from what OBS sees. So I know if things are off, not in frame, or out of focus. Yeah, and this is why I like the having this wool, because this is kind of my technique. I blob it and then I remove it with a clean tip. So if I couldn't clean my tip easily, oops, this became a bit of a mess. Yes, wicked. I think one of these is a ground, and that again requires a lot of heat. And even the smallest tip is still too big. Just a few degrees more. We did add flux. I don't like to sync everything in flux. Or do you mean add flux to drown it in flux? Yeah. Drowned by Rossmann style. I don't get that reference. See, if it's not ground, it works perfectly. If it's ground on 4 layers, God help you. Pretty pleased with flux on top. Nice one. Right, so we definitely need I'm just thinking, where is kind of forgot what is this chip right here, U9. I was looking for the 5.1K resistors that are almost always there on USB Type-C, but this chip takes care of the CC lines because it negotiates. That's why they are not there. But the U9, do I need that for the initial bring up? Okay, that's the digital pot, so I don't need that one. Right. No, so we're good. So we just need the caps, which maybe we don't even need them, but it's nice to have them. Are those 3 by 3 millimeters? Possibly. You would have to check the data sheet. This is the symbol, so check the data sheet for that one. Okay, so C20. So this is quite unusual how I usually do it, because I also use the iBomb, the interactive bomb thing, which actually I have loaded on the screen here, so maybe. Yeah, that actually looks better. So we need a 10 UF 25 volts here. start with the non-annoying side. I don't know if you can see, I have a window in the way. Yeah, there's a big, thick power trace going here. That also requires some heat here, but nowhere near as much as the power ground. Yeah, okay, so now we go digging for capacitors, because I have regular 10 UF in my organizer, but I also need a 25 volt one, because yeah, you can get up to 20 volt on this side of the USB. So we have the container. This is just a few cups. We need one. So this is a decoupling for the chip on the side that powers it, which is supposed to be 3.3 volt, but it also can self-power, so it can power from the USB bus. So this one doesn't have to be 25 volts, so we're good on this side. But yeah, now we go digging again. That's there's a lot of funky value resistors here, because DC-DC for the feedback you need, there's like 73.2 and then 40, 46.4. Yeah, so these are the buttons I mentioned for the latching. I have them in blue, but I have a few different ones, so I can experiment which one works best. Yeah, see you, Brian. 3 hours? I hope not. We'll see how it goes. It's going really slow. I mean, it's been 1 hour. I soldered 1.5 components, so that's going well. The search for cap. Yeah, here I have them in with white tops, but they're taller, so I can decide once I put them in if I want the shorter one or taller ones. Here I have some Type-C connectors, so I can already remove one because we will definitely need it in a moment. There it is, 10 UF. Plus minus 10%, 25 volts. I just dropped one part, don't want to miss any parts. Right, so I put aside because I will need it. I'm really annoyed about the multimeter running out of battery. I think I will fix the battery before we actually connect it, because I just don't want to smoke that chip if it's shorted to ground. Oh wait, that's the wrong, that's not the one. This is for the DC-DC. God. I see there's some 555 discussion in the chat. Are we making 555 BGA boards now? What's happening? There it is. All right, it's not on the camera. That link looks legit. There it is. Interesting that even with dot as a word, it still didn't allow the link. So there you go. Just a boring 10UF 0603. Yeah, Dave Darko is a mod here, so he can, but he's on his phone, so hard modding from. Oh, you can't see the action here. Yeah, so I think we shall diverge and actually do a side quest of replacing the battery in this one, because I really want to test first. I think it's a 9-volt, and I think I have some 9 volts home, hopefully. But yeah, this rate, this will take like 20 streams to solder this whole board. But why not? I would do it anyway, regardless if it's on stream or not. So. Right. I don't think I ever replaced the battery in this one. Oh, okay. I see how it is. Doesn't seem to be a screw in there. Nope. There it is. Just a snap. 9 volt. Just a moment. Okay, so it seems I'm out of 9-volt batteries, but since we are hackers, we're gonna hack the world. So I have this battery connector with wires. So we're just gonna power this sucker from a power supply, 9 volts. I'm sure nothing can go wrong about that. Yeah, who needs batteries when you can just power supply it? 9 volts. There we go. Yep. The backlight worked, but what? Okay then. What? The fuse seems okay. Okay then, I have no idea. We don't have a multimeter then. That's not great. Yeah, the polarity was reversed and I did connect it reversed. I'm not sure, maybe the battery is okay, but it just broke. If... Also, there's no backlight, so the battery is dead for sure. Oh well, oh well. Let's just solder the connector then. the I think it's fine, Conrad. We'll just see how that works. And that ground is oof. Yeah, Grogard. As you can see, I soldered 3 components in an hour, so that's what happened so far. Microphone is in the way. Yeah. Quite annoying because it's really like on the edge of, you can see on the small camera, it's on the edge of the microscope stand. Oh, that was, whoa, there. Where did that one go? I see, it didn't even, wow, it didn't reflow to the ground. It would have been embarrassing. I think I need to get thinner solder also, because this one is not as thin as I want it to be. Yeah, that's not exactly what they say that they mean when they say drag soldering, but if it works, then it works. There, drag soldered. Ta-da! Interesting, you can see this one bubbling because the heat transfers over the ground plane. Not enough flux. That is, I disagree. Look at everything is super sticky and flux. What is the most used word today? I'm sorry, I missed. Yeah, so in theory, we should now be able to actually get some voltage here. Yeah, hot plate would be nice indeed. Right, but I don't have a gosh darn multimeter. Annoying. Really, 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 really annoying. What can I do? Yeah, because I mean, I can just keep soldering, but if I can't measure the voltage, I have some expectations of the voltage levels, and yeah, if they don't pan out, then that's not great. I could solder like stuff here, which the connector and the fuse and the diode and the switch before we get into the DC-DC here. But still, yeah. 10-minute bike ride. Yeah, I don't know, Conrad. Maybe I have to take you up on this offer, because otherwise, really, there's not much I can do right now. Unless this starts magically working again. Yes, I did flip, because let's see the camera. I mean, you can see polarity flips. Thanks, Conrad. So now I have it out of frame. So if I flip it to be correct. Yeah, it doesn't matter, it's 9 volts. Yeah, Gorgard, I'm trying to measure the voltages that they are as expected, because I have the PD, the USB PD here. I assume it starts as 5 volt, but I want to make sure of that yeah, I get the 5 volt that I expect. Then I want to measure all the voltage drops like through the diodes here, through and then as I solder the boost, I want to make sure that I get the 15 volt as expected. Improvise LED. Yeah, I can improvise, but I can't measure voltage. I mean, in theory you could measure voltage with a LED if you find the proper resistor. So, yeah. Yeah, you can see the backlight, but there's nothing on the screen. I should bring, because this is like, you can see this is the small Unity. I have a proper Unity at our hackerspace. I should have brought that one for today. That one has proper sleep mode inside. This one doesn't seem to have that. So while we wait for Conrad to come, What else can I say? Yeah, I can solder the diode there, so that shouldn't be a problem, because that's just since the USB and the battery and the DC in are all, they're all going through, they're all connected together. The diodes protect them from the backward voltage coming in. No, so I checked the fuse. It looks good. Like, I don't think you'll be able to see, but it did not blow. Now, if only I had multimeters, I could test the fuse. Annoying. But yeah, let's find the diode. It will take 10 minutes to find the diode now. Can I show something? I could try. Depends. What's your link, Mark? This is the buck converter. Right, so I found the diode, but I also found that is all of them. Yeah, I ordered 3 different buttons for the hard stop, let's say, but I think this one is larger than these two, so it won't fit. I think I just got it in case I wanted to change in the next rev, because it's a really low profile, which is quite nice. But I think this one doesn't fit. Oh no, it does fit, yeah. Did I switch to the microscope? Like, the microscope is far enough to actually work somewhat well as another camera. So you can see here, yeah, is the switch, because I don't want it to be too tall, but also the DC jack, barrel jack will be here. So where did you send it? Is it your STM board, maybe? Sure, you can send the link, Mark. I can see if I can open it in the stream. No, I don't think so. Is it on Discord or something? Because it's not on, not in the live chat. Yeah, so here you can see there's, oh, now I get it. I heard it. Yeah, here are the 3 buttons that I can consider using. Yeah, I got it on Discord now, so I will check it in a moment. Yeah, so you can see this is purely cosmetic, and I mean a bit like UX. How tall do you want the switch? Because price-wise, they're pretty much the same. This one might actually, it seems larger than my 3D model, so it might, I would have to move some stuff around. But this one looks quite well. But that's, yeah, the button is the least of my worries. I can leave it in right now. Let me just check this thing. Let's see, how can I open this? Right, so I should be able to switch to the desktop now. Yep. Oh wait, the desktop, that's the wrong screen. That's not right. Switch back. Trying to. There we go. Okay, there it is. So there's the board. So what does it do? Is that a battery connector, and then? All right. Yeah, sorry, I missed the part of the discussion in the chat. Is this the 555 something or the other? Banana for scale. Oh. Seems I'm getting a call from Conrad. So you know what? We will go into a break now, and I'll be right back with the multimeter. And we're back. And I have a multimeter. Conrad has delivered Excel. Excel 1. So we can measure stuff and be sure that there won't be any smoke, even though there still might be smoke. We'll see. Yeah, luckily we don't live that far, so we can have that advantage. So what was it? I'm a bit out of the loop of my own chat. Right, you were discussing a 555, then you were discussing BGAs. Hi Dren, yeah, YouTube notifications suck, but you haven't missed that much except for drama, so no worries. Yeah, it's a Unity UT61D, so it's quite nice. But yeah, here is the... Oh, why did this switch again to the wrong monitor? Oh, no, wait. Ah, there we go. There's a 555 BGA chip, I guess. And here it is with a banana. Big tantalum cap. Oops, that's not what I wanted. There we go. No, I didn't send him home. He went home. So before we burn anything, then we can at least try. Wow, these tips are really thick. Yeah, I don't know if I'm penetrating really the flux kind of shell, but it does. Or it does seem okay, so let's see. Yeah, I recognize that was my banana for scale. Right. So should we just go for it? Nintendo. Maybe I should start with a with a non-PD, so we get 5 volts, and then we can see if the PD even works. Yeah, that's better, because the switch power supply supports PD, so it might give you like, what is 60 watts. Yeah, so that this is a non 3.01. Oops. But it's not smoking and it's not hot, so yay for us. It's a great day for humanity. My chip didn't explode. What about some voltage? Do we get any voltage? 4.99 volts. Okay, we have 5 volts, ladies and gentlemen. What a success. And it only took us 2 hours. Yep. So now I connected a Nintendo. And let's see. I'm gonna guess we get, yep, still 5 volts because we don't do any negotiation over I2C just yet. Great. So, Dave, you missed all the multimeter drama. Right. So now we can get going on the soldering. We can solder the diode. We can, yeah. Then we have the fuse and the switch, and we can get into the the boost. My bad. The boost. And if we get 15 volt, I will be happy and done for today probably, because that will take some time. Because once we have the 15, we have to solder pretty much all of this. To get the 3 volts at least. So that's gonna take some time. Luckily, let's see, where are we? I found the diodes needed. There they are. And I quite like LCSC allows you to put custom text. So here you can see USB, battery, and DC, and it's the same diode. I just put the comment so I know what it is. So it's nice. Thank you, past me. There it is. Don't sneeze. There we go. Note to self, buy more 9-volt batteries. Whoa, it just went there. Yeah, the smallest dip is not great for these very big traces. There it is. Just for fun, we can measure the drop on that one. To verify each step, because trust no one. Before we have 4.99, after 4.98. Yeah, this is a really, I remember, low dropout or low drop diode, especially at low currents, and there's like no current right now on this, so there's barely any. Is it multied? Right, I get distracted. So we need a fuse, which means we need to get in that box. I just stopped because I'm thinking, should I solder also these two? Or don't have to, but do I want to? I guess not. Not needed right now. We're good. Searching. Yeah, this is the it's a PMIC, but this is the current sensing, so it's INA 219, and this is the potentiometer. Where's CAT 5171. It's a 50K. So it's a I2C potentiometer, and you get 50K in 256 steps. So you do the math there, how much per step you get. But it's enough. Okay, so there's one fuse here and another fuse, and yep, I got a few just for fun. Yeah, I have a 1.5 amps 24 there. 24 volts 1.5 amps, or I have 12 volts 3 amps, and for some reason I got this one is also 3 amps. I think I'm gonna go for, yeah, 24 volt, I guess. And this is a polyfuse, so it will trigger when you get too much, holy crap, it's thick. When you get too much current through it, then when you remove the current, it will jump back and start working again. So resettable fuse. And look at this beast, it's beefy. It's a chunker. You know, that's a good reflow. There we go. Yep, I think I'm gonna just try on each step, because that's, now we should have a 5 volt also on that side. Just, you know, to be sure. Side 5 volt, this side. Huh. Yeah, 498. I just couldn't get a good connection there. Okay, you figure out posting links. Cool. Right, then we get to the button. I think this one is a nice one. That's not really a big issue. Which one we go for? I'm thinking if there will be a problem here, but it shouldn't be a problem to solder this with the button in the way. Hopefully. Or you know what, let's check if I need hot air for this inductor, because otherwise, if I do, then this button will melt when I try to heat up. So let's find what goes there. There it is. Yeah. Again, it's nice. I put a comment here that this is a 15. This is for the buck. Bye bye, applied procrastination. Thanks for stopping by. No, I guess we don't need hot air for this one. We're good. You can see there's, whoa, nice side pins here, so we should be able to solder that with a lot of heat, I fear. But first the button. So how I do it is, first I just solder the pin 1 kind of by hand, you can see here, just so this button stays in there. And then I can do it nicely now and clean up the short. No problemo. I have a test point here for VN, because at this point, this is where all 3 voltages are in. The battery, the DC-DC, or the USB. We are after the fuse. We are after the button at this point. We're good to go. Man, this is gonna be a lot of soldering at some other point, especially here. This is the display backlight control here. There are QSPI there. Yep. Okay. There we go. We have a nice button, and we can again verify the voltage. Our power paths. Starting projects is super easy. I bet Dave has 95 more just set to private. I know I have a lot. Yep, so the button works. When it's up, it's actually on, and then down to turn it off, which is counterintuitive. But I actually, I soldered it backwards, you know. Yep. It should have been the notch here. Now I remember. That's cool. You can see the action in there. But it doesn't matter that it's backwards. Next time we'll remember. So now we buck it. No, we boost it. Ugh. Why do I get confused? Yeah. Okay. I will change the tip for this because screw those big pads. changing the tip. It's not as painful as expected. I can do it while it's still somewhat warm. So since here we will be soldering beefy stuff, I will maybe go to like 350. Let's see, give it a moment. And while I give it a moment, I should search for these parts. So this inductor, bam, we have. And I was smart enough, yeah, to put aside the boost driver here. And it is MT3608, which is actually, it's everywhere. Like if you ever got a boost board, one of these, okay, that's too big. If you ever got one of these, or let me switch even more. DC-DC, anything to anything boards from AliExpress for like, I don't know, $3. That's exactly what this board uses. So like you can buy the reels of it super cheap because it's everywhere, and yeah, it works fine. Like I did my initial testing using that board, so shouldn't be a problem. And also doesn't require that many components. It's small itself, so hopefully it just works. Famous last words. Come on. We are at temperature. Here 22 UF. Just double checking my bomb. Oh, these are different. Just from different reels. So it's this one and this one. Right, and then there's two resistors and they are fixed to be 15 volt because, yeah, I just boost whatever to 15 volts. There we go. Get in there. That doesn't look good. That's better. And then the resistors. Right. Before I find that, let me just solder the chip, because that's gonna take a moment to find those resistors. So we have the pin 1 indicator here. Let me check, can you see? Yep. pin 1 is here, there's pin 1 line there, so we're good. Here it is. And this is when that thinner tip would have been nice, but you can't have it both ways at the same time. Hopefully I can, yeah, I should have, yeah, we can fix that. There you go. This is what happens when you use stencils too much. You get so used to paste that you fall out of practice. There we go. Oh yeah, and what goes there? A diode. Ah, Conrad, welcome back. Thanks for the multimeter. We are 2 hours in. So yeah, let's solder these 4 components, measure the 15 volt. If we get it, I think we're done for today. I will stream hopefully tomorrow. If not, definitely at least once during the weekend. Is this reflowed? That is my question. Yep. Because I want to finish this board ASAP. Okay, there's 1 resistor. And so many parts in this one. Aha, that's the diode for the boost. But where is my other resistor? Has to be somewhere. Missed it, I guess. There, okay. I had it in my hand. So again, marking your parts is nice. So I know immediately this is the boost diode. There it is. And then we have a 240K and a 10K 1%, which actually is used a few times here. But yeah, with so many components on this board, it was, I think, impossible to go with just one-sided load, even though I'm not a big fan of dual side. It's quite annoying from like reflow standpoint and just assembly standpoint, and all the standpoints really. So, but yeah, even like the big thing was that there's no components other than display. The display is flat on the board, but even if it wasn't, even if it was resting on parts, this wouldn't have been enough. Maybe it would have been enough for the SAMD and friends, but not for the book, the back and all that. And then again, I could have made the board longer, but I really didn't want to. It's already pretty big. It's like 7 centimeters, I think, long, which, yeah, I'm used to my tiny boards. So which one goes where is the question. Yeah, you can't see it, but I have actually I could show you. So this is the screen I have to the side here, and I have the IBOM open here, so I know. Where's my cursor? There it is. So I can easily see pin 1 on everything, and then I can see the values as well. And you can see the rectangles are screwed up because I'm using KiCad nightly and something got screwed up with the script there, but yeah, it still works mostly, and it's awesome to have net info. Like, well, that's a flood, so you can't see, but yeah, just having net like this is awesome. Okay, so there's the ground on this chip, so that's even worse if it's shorted. That's a CC, so it's okay if that one shorts, actually, mostly. Yeah. Okay, let's switch to microscope. There you go. So this whole board, we have a ruler here. Yeah, it's like 6.5 total, which is not that big, but yeah, I didn't want it any larger than that. Anyway, that's how I the script, I had to make a few changes to make it work with nightly, and it still had some issues, as you can see, but good enough. But I have to say I love this script, because without it, it would have been even more of a pain to solder all these. Usually it's even better, because when you're assembling for reflow, then you just do components by values. So, you know, all of the all the 10Ks, all the 1UF, all the and so on and so on. Here it's a bit harder because I'm soldering by blocks. But still, actually, I will wait with this one because I want to have access here. But even here, it's super nice to have the possibility to check the components like this. Okay, let's get this chunker there. Let's see if I need even thicker tip. Maybe it won't be so bad. That actually wasn't so bad, assuming we got a nice reflow there. Yeah. Let me just see what you see. Yep, that looks good to me. It's actually way brighter on the screen than I see in reality. In reality, it's not as bright. There's not as much reflection. I guess it's a bit overexposed in the camera. So yeah, the quality of this microscope is great. It's not as bad as it looks on the camera. Sorry, just reading the chat. Yeah. Yeah, exactly. With this script, it's also nice to assemble like a machine, one value at a time. And that's how I usually do it. For the streams, I wanted to do it differently. Sprinkle. All right, I hope this doesn't smoke. I did it based on the reference design. What did I say? If it's up, if it's down, it's off, right? So let's start it off and see from there where we go. Let me just show this on camera and turn it on. It did not explode. So that's nice. Okay. So if we first measure here, 4.9, and then here, 15. Great. 15.1, which is, I think, what I actually wanted. I think I wanted slightly more. Great. So the first step is actually working. So that's really great. No magic smoke. Oh, don't be... you should be happy that it's a bit warm, but that's to be expected, I would say. Cool. The fuse didn't blow, nothing blew. Exactly. Now we have the fuse, so if this was shorted, hopefully it would have saved my charger. Yeah, I'm just thinking what else, because now I'm feeling like, okay, it works, but what else? And there's not much we could solder. We could solder here. It's 1/4 past. This shouldn't take more than 15 minutes, so maybe just for fun we can do these, and maybe these buttons, because they're, yeah, it doesn't matter if they're too early. Why not? Why not? Yep. There's still 35 people in watching. Thanks so much for not bailing. No explosions is awesome, definitely. Place the multimeter. Yeah, I can do that. Just a moment. It's just hard to have the multimeter and the microscope in frame. But if I switch to this view, right. Glare. No glare. There it is. So, take the journey with me. We start at 0-ish. Exactly at 0. That's actually really nice. And then this is the voltage. Okay, it's a bit higher than before. Interesting. This is the voltage we get directly from the USB. The PD is there, but I don't believe it's doing much. I mean, it is doing the CC 1 and 2 negotiation because there are no resistors, and that chip has to pull it to 5.1K, so we get proper voltage. Oh, what was loud? Sorry, what did I do? The PCB holder on the microscope. Yeah, okay, sorry. It is metal on metal. So we have a 5.2, then we have a volt drop over the diode. We go to 5.1. Yeah, this is metal. Then we are, after the polyfuse, we don't really drop anything. I mean, sure, it's metal, but the board is in the air because it's on the vice, so it's not a problem. And then we have the 15 volt here. Or no, now we have the 15 volt because the button was off. Yeah. Yeah, it might be that there is now a load, so the voltage is actually proper. And the drop should be slightly higher also. See, you can see now. Now it's like a 200 millivolt. Oh, hey, yo. What we can do actually is I will turn off the button, so that will disconnect the boost. Yep. You can definitely see as the current consumption rises, the drop also rises on the diode. Physics or something, I don't know. Oops, sorry for that. Hopefully my shock, what is it called? The mic shock took it a bit. So yeah, let's solder a few buttons just for fun. Because at least, maybe I should disconnect. At least the buttons won't disappoint me, you know. So in most of my projects so far, in like, I guess mostly in Serpenta, that's the only one that has a button, isn't it? Yeah. So in my Serpenta board, but also in other boards that are not public yet, I used these Omron buttons, really, really tiny. And they're quite nice, but I actually recently found cheaper ones that seem to work just as well, if not nicer. And yeah, since they're cheaper, I will try to switch to those now. And it also just so happens that I believe these are the ones also that Adafruit uses on their feathers. So why not? Why not? Johnny is not here anymore. That sounds bad. Yeah, should I move this mic to the left side, because it's really in my way when I fiddle with the soldering iron, and that's not great. Not great at all. Yeah, after I solder these buttons, we can have a feel of how it looks with the screen, and yeah, how it feels if it's too far, too close. Yeah, I appreciate Mark's pun in Swedish, because fem is 5, because it's a 555, but also femto is one of the SI units, or not units. How do you say that? One of the multipliers? One of the scales? One of those. But it's also a 555. Very, very, very pretty funny. Yeah, I'm sensing a problem here because this shouldn't be shorted. Right there. Prefixes, yeah, that's a word. Yeah, hi William. The 15 volt, the first stage worked, so that's nice. There we go. So that's, I'm happy about that. There you go, or there you blur. There. Nice. They're less clicky than the ones I use normally, so I think that's actually good. Yeah, there was some femto drama recently when Seed Studios released or announced a new product. They called it femto something, and then there's the femto Duino, I think, and femto Coin that had their boards for quite some time, and they were not happy with Seed doing that. And Seed actually was nice enough to recognize that, and they, I think, delayed their release for like a month or something and made boards with a new name. There we go. Did I switch to? Sometimes I wish this, because this microscope is just so close to being like a proper camera. As in, not just for magnification, but actually because this is there you go. So that's how it will be with the buttons. Okay, that's as close as we can get without breaking things. Yeah. But this should work really nicely, I believe. We are quite far away from that just yet, because the next step is back. Now we have 15 volt. Now we have to go back from 15 volt to 3.3, 5, and the adjustable one. And that is, like I mentioned, that's a lot of components. Oh, that didn't quite. We could put a bit more solder here. I forgot to put a name on this one. I'm not sure what that is. Or is it? Did I screw up? Because I'm fairly sure I wanted to have D plus and D minus on test pads. But, and I mean, this could be one of them, but then what happened to the other? And where's the label? Was I very sleepy and it was like 3 a.m. when I finished this? Maybe. But that's not a breaking issue. I would just have to double check that later. Unsol on the display. We can do that. As ASAP as possible. That is true. JLC has a minimum board size, but otherwise they're pretty capable for like 4-layer boards. So it seems there's not much they can't do if you just have enough money. I think they can even do buried vias and blind vias. You just need them money. I wonder if I should put like something here to make it softer, like just maybe even rubber legs. Interesting, because yeah, I can imagine that being quite loud. And as I say that, I do it more. So sorry about that. Okay, let's solder these 3 components and we're done for today. We can actually try some 9-volt or something in there and measure that this also works. And we're 2 out of 3 power inputs. Because this one, I mean, we don't need the volt, the whole charging stuff here. We could also just do the battery connector and the diode to measure, to verify that part also, but we don't have to do that today. So right, so that's a 10 UF again, which I think I put it on the floor because I thought I was done with it. I think I should have smaller boxes inside the box just for the parts, to organize them by blocks. So this is for the back, this is for the boost, this is for the CircuitPython stuff. This is really annoying. Though to be honest, it's not as important or not as problematic when you're assembling single boards, because then you do just this bag goes here, this bag goes here. Okay, there's the 10 UF. But we still need the diode. Should be here any minute. Oh. Oh. Okay, I put it here. Cool. I like how the chat discussion is about totally something not really related here, just a different board. But I don't mind it because, I mean, that just, if I inspired someone with my crappy soldering to make another board, then that's a plus in my book. And yeah, remember you can use the coupon JLC Arturo, one word, to get $2 off at JLCPCB. Gotta chill a bit. Because yeah, say what you want. These boards, they're, I mean, again, I cannot complain too much about the quality of the JLC boards. Maybe the silk screen is not as good as the one that OSH Park has, but they use a totally different technology. I saw the other day, I think they claim they have 1000 DPI, which is insane. So you can't really beat that with silk screen like the way they do it, which is a actual silk screen. But yeah, on the other hand, just look here. I made this. This is like, I drew this in KiCad just using, you know, arcs and circles and lines. So it's not really, it's not even a symbol. It's just something I put. No, I don't think so, Dave, because I tried that coupon myself before ordering just to verify that it works, and I was able to use it to get the $2 off. So I think it's every time you get the $2, and it doesn't even have to be like a $2 order. You can order for like $100 and just get $2 off. I mean, it works well best, I guess, if you're ordering like 5 boards for $2, because then they're free and you just pay the shipping. But yeah, I don't think it's limited, and there's no minimum order. I asked them, or maybe, you know, it's $2. I would assume you can't order for $1 and get $1 back. I think. I haven't tried. But yeah, so this symbol here, I wasn't sure if it's gonna come out nicely, but I mean, this is great. This is perfect, exactly what I wanted here. I wanted to have the polarity on the board for the connector, so that's great. And I have a big bag of these connectors here. It's actually 5520, which I think is slightly unusual, because I think normally it's 5521. But I think the fact that the inner part is smaller doesn't really cause that many problems, as long as the other side, the plug, will actually make contact there, hopefully. If it's like a glove. Femto. Yeah, I did a poll or I don't know, some weeks ago on Twitter, asking what is the one correct polarity, and I think like it was a huge majority that said positive center is the way to go. And it seems from the comments I got that some audio stuff uses center negative, but yeah, no one else wants to do anything with that. So I went with this, which seems to be the right way. And actually, I would like to issue a follow-up to a previous stream where I guess it's literally the previous one. And that was, oh, sorry, you can't see. I have to remember to put things in the center. That's not going anywhere. So in that stream, when I was assembling this microscope, I made a comment that there was two power supplies, one for the light and one for the camera, and the one for the light had a label that said light. And then I looked at them and I was like, they're both 12 volts, 1 amp. Why would they put a label? And it's only later I realized that the polarity on the light is actually center negative. So it's really important to actually use the proper one on both, because you don't want to fry either. But since then, I actually took apart this light and I flipped the wires on the connector. So now both are center positive. So I bought a splitter. I don't have it yet. So I can use just one cable for both, like 2 amps. I mean, it's not like both are taking 1 amp anyway, but yeah. I just want to get fewer cables here because it's already quite a mess. Anyway, we have the barrel jack connected now. Socket switch to disconnect the batteries. That's a nice solution. So this board is actually shaping. Oh, that's the mic and zoom. We can. Oh, that's the wrong way. This board is actually shaping up to be quite nice. There we go. It's starting to look like something. We have. There's my pointer. So everything on this side is done. That's great. The buttons are done. Now this is the battery and all the battery charging stuff. So it's not high prior right now. The reset button for the SAMD and a NeoPixel. So that's also, I mean, we will need a reset later when you have UF2, but that's way far. Here you have the SWD pinout for the SAMD. So we'll get to that when we get to that. How much will it cost? I actually haven't done the math yet on everything because I'm still, I can mention that even though we lost some viewers, but I haven't figured out that this is not like the final, this is the first prototype for the functionality. So I haven't decided yet that this is the final even chip I want to use on it, the SAMD, because I would like this to be like efficient, and with CircuitPython is great for prototyping stuff, but it's not the fastest, obviously, because like you have to C code has to interpret the Python, and yeah, it converts it into, I think, bytecode and executes, but still it's not native code, so it's always going to have some penalties. And I would like to use this as a very simple like logic analyzer, so you could graph the pins and graph the analog in. That would be, I think, pretty sweet. And yeah, have it like a logic analyzer and some very, very crude oscilloscope. But for that, you need speed if you want to write that in Python. And yeah, Zephyr. So that's something I'm thinking about, except I don't want to write everything in. So one, I don't want to write everything in C because that's boring. And two, I still want to have CircuitPython because I want that interface for people to prototype quickly. And I know someone tried to get CircuitPython working on Zephyr. So you have Zephyr running, and then you have just a task, one of the tasks in the RTOS, that's just the REPL. And that would be great because then I could write some of the code in, yeah, it was a proof of concept, but just to see, because then I could have some of the code being native in Zephyr, like a separate task, and then also have CircuitPython running. But for that, I'm not sure the SAMD, even though it runs at like 120, and I think you can overclock it to 160, I'm still not sure that's fast enough. I know that sounds crazy, but so I had a different idea that if this doesn't quite work as expected, I can also run it. I can change the chip to IMX-RT 1050, because that the 1050, the price to performance ratio is like just where I want it. The 1010 is too, like, it only has 128K RAM, and the 1060 it's like more expensive. So 1050 just where I wanted. So we'll see how that goes. So that's why the price that was a tangent, why the price. Yeah, I know I can write C module in CircuitPython, but you still have to call it from CircuitPython. And yeah, I know you can add background stuff and so on, but it's not real time. I mean, it's not going to be real time even on RTOS, but it's not real tasks. Yeah, the 1050 is Nice. So yeah, the price, I'm not sure just yet, but let's get this working and we can go from there. Because yeah, once it gets to writing code, my motivation usually goes down. So maybe with these streams, I can also get people interested in this project, because I could send prototypes to people if they're willing to write some modules and some code for that. No problem there. So yeah, we'll cross that bridge when we get to it. Right now, we're just prototyping. What was I saying? So yeah, I was just pointing out what's on this board, if I can get focused. God damn focus. Come on, what's your problem now? Anyway. Oh, hi, Killian. Killen. Sorry, my bad. Yeah, it works. Oops. It's actually just the demo effect is great. Burn that bridge will we cross. What happened to my free deck right now? Huh. Interesting. It was working just a moment ago, everybody, so never mind then. But yeah, on this side, we are mostly done because we don't need the battery stuff. And then, as I said, this side will be pain. But we can do it. And I think that will be it for... now I'm annoyed. Like, why? Why? It was working so well the whole stream. If I switch to my face, can I switch? Yeah, okay. Yeah, it was OBS actually, yeah. Huh. I mean, the hotkeys are global, so I'm not sure why, but... Oh, nice, Mark. That would be great. Like, if I can go on another tangent, that's something I've been thinking about, actually. That wouldn't it make some sense to actually not rewrite, but have CircuitPython or MicroPython run on top of Zephyr, and not only as a task, but actually on the whole HAL? Because right now you need a port for each new family that you have to add. So when you add a STM, you have to write a new port. When you want IMX, you have to write a new port with the GPIOs, SPI, peripherals, and so on. But a lot of this is already implemented in Zephyr, and there's a HAL, there's an abstraction level that if you want a GPIO, you just say, give me a GPIO, that one, and then you say true, false. And if CircuitPython had a port that implements Zephyr's GPIO, SPI, I2C APIs, then you would get all that hardware for free, because it already, if it works with Zephyr, it will work with CircuitPython through that common API. So I think in general, that should, I feel like that should be like a way forward for CircuitPython, actually, because yeah, they have a great community and so on, but it requires a lot of work, and they to work on each port. And I did the initial IMX stuff and then you need to polish some stuff and so on. Then there's the STM port, there's now the ESP32S2, and I believe Scott is focusing on that one. So he won't have time. And I mean, he shouldn't, because he only has so much time, in the day to focus on other ports. So they would need a lot of resources to keep those ports working and adding new ports. But if you only ported to Zephyr, you would get so much for free, I believe. And now there's a lot in the chat, so let me see. Yeah, I think there was a task for that in GitHub, but yeah, the discussion didn't really go anywhere because I mean it's a huge amount of work. I'm not definitely I can see that it's not something you just do in one evening. You can do a proof of concept in one evening, and then there's the issue of who becomes the boss kind of there, because you could have Zephyr be one of the ports in CircuitPython, and then CircuitPython is still the main projects and Zephyr is just one of the ports. But it would probably make more sense to have CircuitPython be just one of the modules in Zephyr, and that requires obviously cooperation from Zephyr people. And I mean, sure, you can fork, but you don't want to do that. And yeah, you have to keep up with the API changes and so on. But I think that would be quite beneficial in the long run. Yeah, because they do already have the Blinka API for running on Linux stuff like Raspberry Pi and so on. But that's quite different. Okay, Scott is a representative. I didn't know Adafruit had a Zephyr representative because I didn't really see them doing anything with Zephyr, so I wasn't sure they were really interested in that one. So that's cool to know. Maybe there is something there, but yeah, that's definitely a huge amount of work and requires planning, and yeah. I don't blame them for being cautious with that one. I'm thinking if I could single out only the 3.3 volt buck for the next stream. So we soldered just enough here, just the one, I don't remember which one is for the 3.3, just enough to have the 3 volts out on this one so we could get the SAMD working. I think that should be possible because they are 3 separate buck converters. So if we just solder, what is required for the chip to work, and then that one DC-DC, that should work, because that would be nice then to get the CircuitPython working, or I mean whatever, just to get the chip up, just to say hello. And then we can go back to 5 volt. The 5 volt is the last part that's only needed for the battery charging. So again, that part, low prio. The adjustable, obviously that's the one that we want. Another thing here is that a few people asked, there's 2 power rails. Can you have different voltages on each? And right now you cannot, because I could have used a quad buck here, but there was I couldn't fit one more inductor, like a DC-DC circuit here. I don't know. Maybe I could have removing all the labels and so on, but I was having a really hard time trying to do that. So maybe in the next revision, in the final product, it will be there. Where maybe we make it a bit more longer. But I really wanted the labels for the first revision, so for the prototyping, so it's easy to find stuff. Because that would be really nice to have one each. But then you need another current sensing circuit, and it's not that much, because it's here. I believe that's the chip. Then you have a current sensing resistor, and there's a decap. So it's just these three. But this current sensing resistor, you can see it's a big one. So it takes some space. But is Lua even object-oriented? I'm not sure. I haven't used it. I used it to write very simple scripts like 15 years ago. So I don't quite remember. Sorry, I'm just reading the chat now. Okay, you have to do your own inheritance. Interesting. Yeah, I think that will be it. We're creeping in on 3 hours. I'm quite happy with the progress. It was a rocky start, as it always is. But we got there. We got the multimeter. Thank you, Conrad. Not sure if you're still watching. But yeah, next time, either tomorrow or during the weekend, we continue. So I think we wrap up now. I don't have a button on my free deck to stop the stream, but there are ways around that. If I can find my cursor. Yep. Okay. So we're gonna wrap up. Thank you so much for watching. Yeah. Thanks so much for watching. For sticking through all the problems. We had a nice chat. The board is so good so far. We'll see next time how that goes. And see you around. Bye bye.